Tidal Lagoons by the Lagoonies. The world is growing, and so too is our demand for energy. The U.S. Energy Information Administration predicts that our demand for energy will increase by 56% by 2040. Currently, 40% of the world's population lives within 100 kilometers of the coast, including many modern metropolises in need of electricity sources that won't diminish air quality or release greenhouse gases that would increase global warming. And for years, energy enthusiasts have eyed tidal power as a clean, consistent energy alternative. But due to technical difficulties in coastal engineering and competitive, inexpensive fossil fuels, tidal power has seldom been implemented. There are three main types of tidal power: tidal streams, tidal barrages, and tidal lagoons. Tidal streams involve small, individual turbine units placed underwater. While they are versatile, they cannot store energy and require large tidal ranges. Tidal barrages can store water behind large dams to gradually output power throughout the day. However, barrages significantly reduce water quality and alter sensitive estuary ecosystems. Tidal lagoons, like tidal barrages, involve a large, dam-like structure, which can be built anywhere with large tidal differences, rather than primarily estuaries. While no tidal lagoons are currently in operation, it is predicted that they provide slightly less power than a tidal barrage, but have a wider variety of viable locations and less environmental impacts. Economically, a lagoon must provide affordable electricity in order for it to be a viable replacement for fossil fuels. There are a number of planned lagoons in the United Kingdom that can provide this information. According to these sources, the average cost per kilowatt hour is predicted to be 14 cents, or $140 per megawatt hour. This makes tidal lagoons a competitive power source when compared to wind and solar, although they still lose out to traditional hydroelectric, conventional coal and other fossil fuels, and advanced nuclear. Tidal lagoons have their limitations, however. They require large perimeters and alteration of existing coastlines and ocean currents for tie-in points, and are slightly less cost-efficient than other power options such as fossil fuels, as mentioned earlier. However, they do produce less emissions than fossil fuels. Sometimes, problems can provide solutions. At low tides, the top of the lagoon would be exposed and would provide recreational space. Lagoon walls also protect the coastline from storms and consequently save time and money by reducing work involved with repairing coastlines. Lagoons also allow animals to swim freely during high tides and have less of an impact on sensitive estuary ecosystems. They can also provide shelter for small fish and waterfowl. Furthermore, they have the capability of powering large swaths of land. In summary, tidal energy is a consistent, reliable source of power with three methods of harvesting: tidal streams, tidal barrages, and tidal lagoons, each with their own benefits and drawbacks. Tidal lagoons handle all aspects of the triple bottom line very well. They can provide significant amounts of power at competitive prices, have numerous social uses and benefits, and have lessened environmental effects compared to other power sources, whether they be fossil fuels or tidal barrages. Thanks for watching. That's all, folks.